Yeah, children, students, you know, our Madam Snega, she started teaching from last class. She'll be, helping us in supporting in science classes to our students. Make use of her. That's the only thing I wanted to tell you. Make use of these wonderful, teachers whom we have. They're all very bundle of knowledge. So it's up to us to make use of them. It's up to me to make organize everything, and it's up to you to make use of the class. Listen to the class, raise questions. Whenever she asks something, you can answer. Maybe it's wrong or right, never mind. But you keep talking so that the class become very lively. Okay. Thank you, madam. Go ahead, madam.
All right. So, good evening, everyone. I hope
Good
I'm
evening,
visible
ma'am.
and audible. Am I audible enough?
Yes, madam.
Yes, ma'am.
Okay. All right. All right. All right. Mm. All right. So, in the previous session, we undertook the concept of structure of the atom. We understood how the different particles of the atom, like electrons, neutrons, and protons, were discovered, which type of experiments were undertaken by various scientists. We also learned how important it is to understand the structure of an atom, because all the chemical compounds, all the compounds existing in nature are due to the structure of the structure of atom. So today we will understand how the bonding is formed between two atoms, between two elements. We will understand what valency is, how valency plays a role in bond formation of two different elements, and we will go ahead with the different aspects of an atom, like atomic number, atomic mass, or mass number, what we say. And we will understand the difference between mass number and atomic mass. There is a difference, very minute difference, but you need to understand what that difference is. All right, so let's begin with today's session. I'll share my screen. Give me a moment. Okay, just let me know if the screen is visible.
Yes, ma'am. Yes,
Okay.
ma'am.
Okay, and my voice is clear.
Yes, ma'am.
All right, so let's go ahead with the second part of this chapter, that is the structure of an atom. Today we will understand what electronic configuration is, what valency is, atomic number, mass number, and isotopes and isobars. Let's go ahead with electronic configuration. Now understand that in the previous session we understood by the experiment of Rutherford that the structure of an atom is like a sphere, and there is a smaller sphere inside the atom in the center,
Nucleus.
which contains all the mass of the atom, which is that is the number of protons and neutrons. And the electrons, the negative charges, revolve around the nucleus in circular orbits. Now the question must arise: why electrons are revolving around the nucleus? What is the answer to that question? Why do electrons revolve around the nucleus? Can anyone answer that? The answer is very basic. The answer is that the charges of electrons is negative, the charge of protons is positive, and there is a force of attraction between negative and positive charges. the mass of protons is much greater than that of electrons. So the negative charges are easily attracted towards the center of the atom uh, under the effect of the force of attraction that we also call centripetal force. You must have understood centripetal force in other parts of physics. That is the force that keeps an object bound to the center. Here the center, okay. Here the center is your nucleus, where all the force of attraction is accommodated by the protons and neutrons. Neutrons, though, do not apply any force of attraction, but the protons, with their positive charge, attract the negative charge of electrons. Correct? So electrons have a habit of revolving around the nucleus in circular paths, as per Niels Bohr's model. Okay. Now, Niels Bohr suggested that there are four or more orbits depending on the number of electrons present in the atom or in the element. So, how are these electrons arranged? Is it like randomly, if there are 8 electrons in the atom, completely 8 electrons, so all the 8 electrons are in the same orbit? No, it's not like that. He said Niels Bohr said that these electrons have discrete orbits. What you understand by discrete orbits is separate orbits with different number of electrons. This enables the orbits. The presence of discrete orbits enables the atom to be stable, to be neutrally existing in nature, to be neutral. Okay. Now, this is because why they are stable is because they have very specific number of electrons in each orbit. So in the first orbit there are 2 electrons. In the second there are 8. How do I say these numbers? Because Bohr and Bury, the scientist duo, gave a formula. Gave a specific formula to find the number of electrons in a particular number of orbits. And that number of electrons is 2n square, where n represents the number of orbit in the atom. So if it is the first orbit, the maximum number of electrons will be 2 into 1 square, that is 2 into 1, that is 2. Second orbit, it will be 2 into 2 square, that is 2 into 4, 8, and so on. Similarly, you can go ahead with many number of orbits depending on the number of electrons present in the atom. As we know, there are 118 different elements and many more to be discovered. 118 elements means there are atoms with 118 electrons. Like in the previous session, I said that you will understand these orbits are divided into subparts as well. When you go in the higher classes, you will understand how the configuration is, how the electrons are accommodated as per this configuration in various subparts of the orbit or suborbits we call. But for now, you need to understand that in the first orbit, there will be 2 electrons. In the second, there will be 8. In the third, it will be 2 into 3 square, that is 2 into 9, that is 18, and so on. But But when we talk about the outermost orbit of an electron, that is the final orbit, the last orbit of the electron, the maximum number of electrons that can be accommodated in that orbit is 8. And that achievement of having 8 electrons in the last orbit, we call that state of the atom as an octet. Octet means the state of an atom having 8 electrons in its outermost orbit. Having 8 electrons means the atom is completely stable. It is non-reactive. It will not react with any other element because it does not need to achieve the stability. Why do atoms react with each other? Why do they form bonds? Why do they form compounds? Because they are not stable. Yes, naturally they occur stably, but whenever they come in contact with other element which is not stable, they both become unstable and react with each other. And the ultimate purpose, ultimate goal of any atom is to achieve an octet, to achieve a state where they have 8 electrons in the outermost orbit. And for some cases, let's go ahead. If you see here the electronic configuration of sodium atom. See, there are how many electrons in sodium? What is the atomic number of sodium? It is 11. That means in total there are 11 electrons in the sodium atom. So it is not like in the first orbit itself they have put 11 atoms, 11 electrons. I'm sorry. What they have done is there are 2 electrons, as you can see in the figure. There are 2 electrons in the first orbit. Then there are 8 electrons in the second. How many are left? Only 1 left. So the one remaining electron will be in the outermost orbit. So can you say this is a stable atom? No. When this will come in contact with another element, it will instantly react and it will try to form the bond with it by trying to achieve an octet. How they do it, we will understand later. Okay, so writing all the or representing all the electrons in the first orbit itself is wrong. What you do is you present these electrons as 2, 8, 1, depending on the number of electrons present in the particular atom. Any questions by far? If anyone has any questions, please raise them right now. Any questions?
No, ma'am.
All right. Okay. So now let's understand what valency means. See, if you understand this electronic configuration in the sodium atom, how many electrons do you see in the outermost orbit of the atom? There are 1 electron. That is, there is 1 electron in the outermost atom orbit of the atom. That 1 is called its valency. It's not valency, but the number of valence electrons. Okay, valence electrons is the electrons present in the outermost shell of an atom. The number of valence electrons for an atom to be stable is 8. Like I said, in the outermost shell or orbit, if there are 8 electrons, the atom is stable. Exception, I have written helium. Why? Can anyone explain why helium is an exception here? It is stable, it is an inert element, but it does not have 8 electrons. Yes?
Ma'am, it has 2 protons, ma'am. Helium has 2 protons.
Protons or electrons?
Electrons, ma'am.
Right. Like when we talk, it also has 2 protons, but when we talk about valency or we talk about outermost orbits, we say that helium has only 2 electrons.
Yeah, yes,
Nitrogen
ma'am.
has 1 and helium has 2 electrons. So there is no chance of having 8 electrons in the outermost orbit for helium. So when it has 2 electrons, that is its only orbit. It has only 1 orbit of electrons. So if its only orbit is completely accommodated with electrons, it is stable. Correct?
Yes.
So for most atoms with electrons less than 8 in number, the outermost orbits will be filled with 2 electrons only. It will go up till, I think, nitrogen. Because nitrogen has how many electrons in total? How many electrons does nitrogen have?
7, ma'am.
7. So nitrogen will, there is a chance that nitrogen will gain the electrons. I'll explain that later. This was a error on my part, not nitrogen. We will talk about that later. Okay. The elements with stable atoms are called inert elements. There is helium, there is argon, there is neon. All these are stable elements because they have completely satisfied last orbit, outermost orbit. So what about the elements which are not stable? What about the elements which are not inert in nature? The word inert itself means non-reactive, non-active, right? So what they do is they try to achieve an octet. How do they achieve an octet? By sharing, gaining or losing electrons. What is gaining or losing electrons is easy to understand because see, when I said, when I talk about sodium, Na, it has 11 electrons in the outermost orbit. Look at this figure. It has electrons, it has 11 electrons in the outermost, or sorry, it has total 11 electrons, and there is only one electron in the outermost orbit. So what is easier for sodium is to lose one electron than to gain 7 electrons, because to lose one electron will require much less energy as compared to gaining 7 electrons. So sodium metal, what it will do is, it will give one electron to another atom. Now which atom will accept that electron? That other atom must have 7 electrons in its outermost orbit, so that when it accepts one electron, it becomes 8. So it becomes stable. And here, when sodium loses one electron, the outermost orbit, what is the configuration of sodium? 2, 8, 1. So it is losing one electron. So what is the number of orbits left? Only 2 orbits, and there are 8 electrons in the outermost orbit. So it will become stable. And here chlorine, when I talk about chlorine, the electronic configuration of chlorine is 287, because it has in total 17 electrons. So again, it is also unstable because the outermost orbit has only 7 electrons while it needs 8 to finish the octet. So what happens is, when Na, sodium and chlorine come in contact with each other in a particular environment, sodium loses one electron, it gives the electron away completely, and chlorine accepts that electron in its element, in its atom. So now sodium is also stable, chlorine is also stable, but they have exchanged the electrons, so they cannot go away from each other. So what they do is, they stay together and form a different compound, which we know as sodium chloride, which is nothing but your common salt. So this is how chemical bonding is formed. So now you understand the most common compound which we come across in everyday life, that is sodium chloride, the salt that we eat in everyday food, is because of this electronic configuration, the structure of the atom. This is what I was saying, why it is required to understand the structure of atom. This is how your common salt is formed. When Na, that is sodium, loses its one electron to gain stability. See, understand this as a part of chemistry or philosophy. Everyone lives to gain stability in life. Okay, every element wants to be stable, correct? So sodium, when it has only one electron in its outermost orbit, it is unstable when it comes in contact with chlorine. So it gives away one electron, chlorine accepts one electron, both are stable. So both come together and form a bond. And they call it NaCl, that is sodium chloride, the common salt that we eat every day. This is called ionic bonding. We will understand that again. Ionic bonding is when there is an exchange of electrons. One is losing it completely, another is accepting it completely. Okay, the ionic bond is much stronger as compared to the other bond that we are going to study right now. Okay, so this is what elements do to gain or to achieve an octet, gain or lose electrons, correct? Another way of achieving an octet is by sharing of electrons. Now, to understand sharing, we will understand the concept of hydrogen formation. As we know, hydrogen is existing in a diatomic form. What do you mean by diatomic form? It contains two electrons, two atoms to form a molecule of naturally occurring hydrogen gas. Why does it have only two atoms? Can anyone answer that? Why cannot it occur as only H? Anyone? All right. It is because hydrogen has only one electron in its outermost orbit. but and it has only one electron all over. Okay, it does not, it is the smallest element known to mankind. It is the smallest element, it has only one orbit and only one electron in it. So it is not stable with only one electron, correct? It has to have at least two electrons to be stable, to be existing. So what it does is it comes in contact with another hydrogen element, hydrogen atom, and they share their electrons together. That means what is sharing? This electron is also mine, this electron is also mine, this is yours, this is yours. This is sharing. Like I have one hydrogen, if you look at this hydrogen atom has one electron, another one has another electron. They come together and they share their orbits. And as they are sharing their orbits, the molecule is H2. It exists in diatomic form. Understood? And this diatomic form, because it is done by sharing, it is easier to break that bond. This we call as covalent bond. Covalent. Co means sharing. Valent stands for the term valency. Okay. So covalent bonds are easier to break. That is why they are mostly covalent bonds occur in gaseous forms. Okay, as you can see, NaCl, the ionic bond is forming a solid, while the covalent bond is forming a gaseous compound. All right, are we clear with this? Does anyone have any doubt?
No,
Any
ma'am.
questions? Yes, anyone?
No, ma'am.
Okay. All right, so I'm going ahead with the next part. Now, understand here what is happening in this case is Na is losing an electron, Cl is gaining an electron. That is clear. Now, when you lose a negative charge, that is, you are losing an electron, you are losing a negative charge. What happens to that element now? It becomes positive. See, understand that the number of protons and the number of electrons is same in an atom. That is, if there are 11 electrons in sodium, there are 11 protons in sodium. Okay. That means if one electron is removed out of it, if there are these two are equal, electrons and protons are equal, then and then only the charge is neutral. Okay. But now one electron is leaving the atom. This means that the number of protons has exceeded the number of electrons. This means that the positive charge is more than the negative charge. So this ion, this sodium becomes positively charged. So understand what you mean by positive valency. When an atom loses an electron to achieve an octet, it gains a positive charge. The question is why? Because it loses negative charge, protons become higher in number. That is why it becomes positively charged and forms a positive ion called a cation. When when an atom loses any charge or gains any charge, it no more remains an atom. An atom is always stable, an ion is always unstable and ready to react. Okay. So when it becomes an ion, we call it cation if it is a positive ion. If positive ion is formed, then it will look for a negative ion to make bonds. Now, negative valency is similar to positive valency, but when an atom gains an electron, again the same concept applies. Here in chlorine, there are 17 electrons, 17 protons. But now, after gaining that one extra electron, it has become 18 electrons and 17 protons. So the negative charge is more. So chlorine becomes negatively charged. Now, this is what we call a negative ion. Now again, negative ion has been formed, positive ion has been formed. When they come in close contact, they attract each other again by positive and negative charges and they form a bond. Here I have written examples, but I have explained the examples through NaCl. You can definitely go ahead and look for other examples how ionic bondings are formed. Okay. Now, this is a very interesting question. What do you think? What do you think will which kind of elements will form cations? Cations are positive ions. Anyone can answer that? See, like on
Metals, ma'am.
yes, yes.
Metals, ma'am.
Why metals? Why specifically metals?
Ma'am, metals lose their valence electrons, ma'am.
Why do they lose it?
To form octet, it loses, ma'am.
No, no, that is right. That is right. But to form, they can also gain electrons, right? But why they don't gain electrons and they only lose electrons?
If they gain electron, it the number of electrons increases and it does not form octet, ma'am.
Okay. Let me give you this example. Let's talk about NaCl only. Na has one electron and Cl has seven electrons. To form an octet, any one of them, I mean, both of them have to have eight electrons in their outermost orbit, correct? So, what if Na gains the seven electrons? What if the Na atom gains the seven electrons and chlorine loses all seven electrons? Why is that not possible, and why the opposite happens? All right. Let me explain this with a very basic example. uh, uh, when we are playing something, okay, and you are in a circle, you are joined together through holding hands, okay, and someone has to run and break through your chain of people. So what is easier, if there are two people to run through them or there are seven people to run through them? What is easier?
Two people, ma'am.
Two people. So the same aspect applies here. The in nature, everything happens with the usage of energy. See, for nature, for physics, for chemistry, energy is money. Like in real life, we always think about what is less expensive for us to buy. Okay, they also think the same for energy also. Whatever requires less energy, they will do that. Any form in physics or anything in chemistry, whatever requires less energy, whatever requires less effort, they will perform that. So it is much easier, much less energy consuming to lose one electron than to gain seven electrons. And for chlorine also, it is much easier to gain a single electron than to lose seven electrons, because it will need much more energy to break the force of attraction between the protons and electrons, where there are seven each. Okay, seven electrons, seven protons are getting attracted to each other, so it is very difficult to break that bond. That is why most metals have in their outermost orbit either one, two, or three electrons. When you go through a periodic table, I'll suggest you to look for the periodic table and see the number of electrons in the metals. It will be either in the outermost orbit, they will either have one, two, or three electrons. Then when we shift to the next part, the non-metals will have five, six, or seven electrons in their outermost orbits. That is why metals and non-metals mostly react with each other. All right, so that is the reason why metals form cations and non-metals form anions. Cations are positive ions, that is they lose the electrons, and anions are negative ions, that is they gain the electrons. Is that clear now, everyone?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, I have the screen open, so I cannot see the meeting screen. So if anyone has any question, please unmute yourself and ask the questions. Okay.
Ma'am, lithium is an example of metal, no, ma'am.
Yeah, lithium is a metal.
Okay, ma'am.
Okay. So now this is that is how we end with the valency, the concept of valency. Is there any question regarding this? Because we are shifting to another concept now. All right. So now we come to the concept of atomic number. Atomic number is very easy to understand. Atomic number is nothing but the number of protons present in the nucleus of an atom. The atomic number represents the number of protons in the nucleus of an atom, which determines the chemical properties of an element and its place in the periodic table, where it will lie. For example, the hydrogen atom has one electron, so it is in the number first. Okay, second helium, third lithium, fourth beryllium. That is how the number of protons, the atomic number. That is the list. Serial number of elements in the periodic table is nothing but the atomic number. The protons, why? Like we know that protons and electrons are same in number. Then why do we write atomic number as only the number of protons and not the number of electrons? Because electrons are freely moving and the number of electrons in an atom can change when they form the bond, but the number of protons does not change. That is why you be specific when you define atomic number. Be specific to write the number of protons only, not the number of electrons. This is how you represent the symbolic way of writing atomic number. Here 1 is the atomic number of hydrogen. You write the symbol, and on the upper left corner you write the atomic number of the uh, element. All right, the symbol for atomic number is Z, capital Z. Okay.
Ma'am,
And
0.008 is the mass of the hydrogen, ma'am.
0 point,
Sorry, 1.008, ma'am.
that is the atomic mass of hydrogen. We will come to that once we are done with mass number. We will understand the difference between atomic mass and mass number. Okay.
Yes, ma'am.
So now we move to mass number. It is nothing but the number of protons and the neutrons. Like we said in the Rutherford's experiment, we understood that the entire mass of the atom is centered in the nucleus. The only heavy part of the atom is the nucleus. So where does it gain its weight from? It is from the number of protons and neutrons. Mass number, I use the word number because it is number of protons and neutrons. It is not the mass, specifically mass of protons and neutrons. Okay. The total number of protons and neutrons in the nucleus of an atom is called its mass number. This is how you represent a symbol with its mass number and atomic number. You write the symbol of the atom or the element. On the upper left corner, you write atomic mass, that is mass number. Here you write the atomic number, that is A and Z, and this is how it is represented. Now understand that when we write 7 lithium 3, what does it mean? That there are 7 total protons and neutrons is 7, and there are 3 protons. That means the number of neutrons is 4 here. Understood? All right. Now let's understand the difference between, this is what I am saying, why we write mass number and not atomic mass. See, mass number is specifically used for weight of the nucleus of an atom, while atomic mass is the average weight of an elemental form. A specific element, when we weigh it, we get a mass, atomic mass. When we talk about the number of protons and neutrons in the atom, we call it mass number. Mass number is written on the upper left hand corner of an elemental expression with a symbol A, but atomic mass is not symbolized as such. Okay. Isotopes we will understand in the later part, but understand that mass number does not take the existence of isotopes into consideration as it relates to the weight of each atom separately, while atomic mass relates to the average weight of an elemental form, and therefore it takes into consideration the existence of isotopes and their abundance. How they exist. We will understand what isotopes is, and then I will explain this point specifically. Mass number is usually a simplified number because we talk about the, yes. Kindly mute yourselves, please. Okay. Mass number, when we talk about mass number, it is the number of protons and number of neutrons. So there is no point of keeping a decimal there, right? They are simplified numbers, they are whole numbers. But atomic mass deals with several decimal values as it is a weighted average. We actually take the element and weigh it on a scale, weighing scale, and then we come to the conclusion of what atomic mass of that particular element is. The mass number is easier to use for general purposes, while the atomic number is useful when performing specific calculations. Alright. Now we come to the concept of isotopes, and then I will explain this point why mass number and atomic mass, one considers the isotopes and one doesn't. Okay. Okay. Now isotopes means, are we clear with atomic mass and atomic mass number and atomic number?
Yes, ma'am.
Okay. Alright, so isotopes are what? Isotopes are elements with the same atomic number. That means the element is the same. It is not a different element. But the mass number is different. So what will differ here? It is the number of neutrons that will differ, right? Because atomic number is number of protons, mass number is number of protons plus neutrons. So atomic number is same. That is, the number of protons is same in both the isotopes. But the different mass number results from having different number of neutrons. Correct? Here is an example of hydrogen, deuterium and tritium. What happens is, hydrogen has no neutron. The originally existing hydrogen has no neutron. It is written as 1H1 because it has only one electron and one proton. Deuterium has one proton and one neutron and one electron. So it is written as 2H1 or capital D. While tritium has one proton and two neutrons. There is a difference in the number of neutrons. It is written as 3H1 or capital T. These are isotopes of hydrogen, and there are many other elements with different isotopes. I think you should all go and look for those isotopes and come up with certain examples of different isotopes, right? This is your biggest task for today. Understand this. I am just giving you the applications of isotopes, how isotopes are used, where isotopes are used. You have to find out why and how they are used in certain fields. Uranium isotope is used as a fuel in nuclear reactors. Nuclear reactors are nothing but power plants where nuclear energy is generated. Isotope of cobalt is used in the treatment of cancer. Go and find out how. An isotope of iodine is used in treatment of goiter. You have to find which isotope, you have to find why that specific isotope, and you have to find how it is useful in such practical fields. Alright? Okay.
Yes,
Now
ma'am.
there is an important or interesting fact about isotopes of chlorine. What happens is, chlorine, like we said, well, like we discussed, that atomic mass number is what? Number of protons and number of neutrons. And atomic mass is what? When we take a actual sample of the particular element, we get the average weight of that particular atom or element, correct? So when we took the sample of chlorine, it turned out that its mass was not 35. Actually, like we discussed, chlorine has 17 protons, correct? 17 electrons and 17 protons. The remaining 18 are neutrons. But so its mass number becomes 35. But in nature, the weight should also be 35, but it is not. It turns out to be 35.5. Then why that difference is coming? The difference is because there are two isotopes of chlorine in nature, we know, that is 35Cl17 and 37Cl17. There are two chlorine forms, one with 18 protons, another with 19 protons. Sorry, actually 20 protons. So the total atomic mass becomes 37. So in nature, chlorine occurs as a mixture of two isotopes, 35Cl17 and 37Cl17, in the ratio 3 is to 1, that is 75% and 25%. That is, if we take a 100 grams of chlorine compound, naturally occurring chlorine compound, we will say that 75 grams is this chlorine, which is 35Cl17, and 25 grams is this chlorine, which is 37Cl17. So its mass is calculated like this: 35 is the mass of first chlorine isotope. So 35 into 75 percentage plus 37 into 25 percentage. So by calculation we get 105 plus 37 by 4, and that is how we come up to the value of 35.5 atomic mass units. That is why the mass of naturally existing chlorine atom is 35.5, because when we calculated it practically, the sample of chlorine weighed 35.5 and not 35. All right, is this clear? Is this easy to understand? Any
Yes,
doubt?
yes.
Okay. This is the last topic, and this is a very short one. It is there is nothing more to understand here. Isobars are nothing but elements with different atomic number. That means there are two different elements only. Same atomic number represents same elements, but different atomic number themselves become different elements, and they have same mass number. That is, they have same uh, total. The sum of electrons, protons, and neutrons is same. It can vary, it can be for any other elements, but it is not as complicated or as interesting as isotopes. Is this clear? And this is the last part of the session. Clear? All right. So I'll stop sharing the screen now, and we will take the queries. All right. So do we have any questions?
No, ma'am.
No questions at all?
No, ma'am.
Today,
No, ma'am.
okay. Today I'll be sharing an assignment of a certain number of questions related to this chapter. You will have to write, or you will have to solve that on your own. You can submit it in the group or in person to sir or me, and I'll go through it and give you evaluation. Okay.
Okay,
Because
ma'am.
the last session was
Okay,
a
ma'am.
part one, I didn't share any questions, but this, after the completion of this part, the structure of an atom, I'll be sharing a small assignment.
Yes, ma'am.
Is that all right, sir? Sir, are you there?
Yes, madam. It's over?
Yes, sir.
Yeah, yeah. Okay, okay. No problem.
Yeah, I'll be sharing a small assignment for the students in the group.
Okay, okay. Thank you, madam. Thank you.
Okay. So we are done with the session today, sir.
Okay.
These students don't have any doubts. They are very well understood the concept really well.
Yeah, you just send some that assignment, then we can find out how far they have
Yeah,
understood.
exactly. That is why I